Hi everyone. Good morning, guys. Very good morning, all of you. Right? Yeah, Pulkit. Yes, correct. Right. So that I did not observe this wrought iron. Yeah, wrought iron was there. If wrought iron was not present, now mild steel is the correct answer. Yeah. Okay. Don't worry. We'll check it. Right. Even I also did not check it. I overlooked it. Right. Don't worry. So here, anyone having any doubts in our yesterday's discussions? You can say, all of you. Anyone having any doubts in our yesterday's discussions? Anywhere, all of you? No, that is not twisting iron. Okay, so all of you, so this is live test we'll be doing. Low carbon, very low carbon content it will be having. So here live test 2 on the materials part 2, that is your target government job series, right? Instead of SSC JE 2024 target, I am keeping it as target government job series, right? Because all state examinations we are going with, and also we are going with which one? State examinations and SSC JE questions series will be doing here, right? Materials part 2, right? Strength of materials will be doing, right? All of you, welcome to Unacademy. Let's crack it. This is my profile. You follow me. If not following, start following my profile, everyone. This is a referral code you have to use for subscriptions, right? Yeah. Rishikesh, Ram, Kavya, good morning. Pulkit, Shruti, everyone, good morning. Breakfast over, all of you, everyone. All of you done your breakfast or not, all of you? Yeah. Yes, very good. So this is the referral code you have to use, all of you. RP Civil, right? Whenever you are subscribing to this Plus and Iconic courses, right? Yeah, Kavya, hi. Over, very good. So April 13th, new batch was started. There I have started this advanced surveying at the same time, and KP sir has started irrigation engineering, right? No, actually this is not there now. Okay, so these are the features of this Plus subscription. Okay. Other Kavya, both Kavyas are there, right? So these are the toppers of this SSC JE 2023 from Unacademy. Now coming to this. So here, what is it? You can say this first chapter, basic concepts of simple stresses and strains. You can say. Now, here this is a ninth question. Do you remember, everyone? This is a ninth question which we have done yesterday, right? That a ninth question we have done yesterday. What is that actually given? Ductility of which of the following is maximum? So ductility should be maximum means what is that? You can say, everyone. That ductility should be maximum means, right? What is the condition to be satisfied? Everyone tell me. Ductility should be maximum means that carbon content should be least, na? So no, carbon content should be least, right? So for which one you will be having this least carbon content? Tell me among all of them. For which one you will be having this least carbon content among all of them? If you just observe, that is your wrought iron. It is 0.08 and mostly lesser than 0.1% only, right? Lesser than 0.1% only you will be having, right? Yeah, 0.08, okay, you can consider, but lesser than 0.1% only most of the situations you will be getting, right? But a mild steel, what is that? You can say it is a low carbon steel. So low carbon steel means that 0.25 to this 0.3 percentage, right? Like that, around that it will be there, na? 0.25, 0.35, right? Like that it will be there, right? Therefore, yeah, again Monday started, Tuesday also will start tomorrow. Okay, so wrought iron will be the correct answer. I did not observe that wrought iron is there. I thought something else is there. So why nobody also observed? Only Pulakit observed correctly in yesterday's class. So in the hurry burry, nobody also observed. Everybody, right? So this 12 questions we have done in the yesterday's class, na? Listen, don't know. Okay, 12 questions we have done in the yesterday's class, na? Right now we'll be going for this 13th question. Right? Shall I start the poll? 30 seconds only time I will be giving now. Yeah, yes. Good morning, Pawan. Pulkit always genius. Okay, very good. Yeah, select the answer of you. Write your answer, YouTube people. Write your option there. Yes, Kishore correctly answered. Right, this question, 13th question also you try to write the answer. So that engineering mechanics wala questions also we'll do in the first chapter only, all of you. Okay, here engineering mechanics wala questions also we'll do in the first chapter only. That moment of inertia, those kind of questions are there, na? I'll do in the first chapter only. Okay, right, you are cute fellow now. So this is the leaderboard, you can say. Now what is it? You can say a material is called as ductile if When you can call this material as ductile? If little plastic elongation or this long plastic elongation could be hammered into thin sheets. So this could be hammered into thin sheets means, right, that is your malleability na. Thin sheets under this compression means, right, what is it you can call it as? That is called it as ductility, or that is called as your malleability, you can say. That is called as your malleability na. Shows a large elastic strain. No. So whenever you are having this mild steel na, how it will be showing, you can say, if you just observe, small elastic strain will be there, right? Among this, right, what is it you can say? Up to this only, that up to this elastic limit only, this is your elastic strain na. And what is this one? This is your plastic strain na. So general ductile material means it will be showing more amount of this plastic region or small amount of this plastic region. Tell me, very large amount of this plastic region it must be showing na. Sana, Vaishali, good morning. Yes, very large amount of this plastic region it will be showing you guys, right, like that. Shall I move on to the next question, all of you? So I'll be moving on to this next question, right? Try to select the answer of you. Write the answer, everyone. YouTube people, write the question number and answer. So yesterday somebody asked, na, this screen is okay, right? This much screen. So I have changed the settings. Yeah, this is the leaderboard, you can say. Pulkit first, Venkatesh second, and Pawan third, right? Yeah. Vandana said correct from YouTube. The moment of inertia of this cross section about x-axis axis is, right? What is the moment of inertia about this x-axis axis? If you just observe, what is the moment of inertia about this x-axis axis? BD cube by this 12 na? So this is your B into that capital D cube by this 12, right? Which option is correct? That option B only comes to be correct, or not? Option B only comes to be correct, you can say, right, like that. So 15th question, shall you go for? Yeah, cube of, yes, cube of this cutting axis, or which one is perpendicular to the bending axis, right? Whichever is present perpendicular to the bending axis na, that you take it as cube, right? That is why if you are having more depth perpendicular to the more dimension perpendicular to the bending axis na, so moment of inertia will be more, section modulus will be more, automatically bending strength will be more, right, like that. Yes, bending axis, there is no cutting, actually bending, you can say, exactly, right? Cube of which one? This perpendicular to the bending axis dimension. If it is a shear na, we can use the term cutting, but here bending na, we cannot use the term cutting, you can say. Okay, right. So shall I go for this 15th question? Select the answer. Yeah, BB Aravind answered correctly. Yes. Any YouTube and special people? Vandana, 4th question B answered. Okay, selected correctly from YouTube. Yeah, from special also. These people answered correctly, right? Pulkit first, Venkatesh second, and Pawan third, right? This is the leaderboard, you can say, right now. So we'll move on to this, right? What is it you can say? Poisson's ratio is defined as which one? Longitudinal strain by this lateral strain, or lateral strain by this longitudinal strain? Tell me. That Poisson's ratio will be which one? This lateral strain by this longitudinal strain, na? Just a lateral strain by this longitudinal strain, or it is minus of, we have to take it? Minus of that we have to take it, na? Minus of lateral strain by this longitudinal strain we have to take it, right? Yes, na? Because that why minus we have taken? Because lateral strain may be compressive, longitudinal strain may be tension. So minus will come now to eliminate that minus, only to get the number, that minus is used, right? And here, so that longitudinal may be tension, so longitudinal may be compression. So then if you are applying compression in this length direction, tension will occur in the width direction, so it may be tension, right? Now also it will come which one? This ratio comes positive. So to make it ratio comes negative, to make this ratio positive, this minus is used, right? There is no other way. Now, so shall we go for this next question of you? Right. Select the answer. So you previously answered now. Okay, this one is the answer. Yeah, now. Vice versa. Yes, correct. Around correct. So select the answer for the 16th question, everyone. All SSC PVQs will solve and all state PSC PVQs will solve in this series. Okay, don't worry. Of whatever the subjects I'm teaching, I will be solving. Right. See, Ravind answered correctly from YouTube. Right. This is a letter about modulus of rigidity is expressed as, right? Which one? Modulus of rigidity will be shear stress by this shear strain. Na? Young's modulus is what? Normal stress by this normal strain. What is that? A shear modulus, you can say. Shear modulus is your shear stress by this shear strain, right? So tau by this phi or gamma, whatever the symbol you wanted to use, you can use, right? Bulk modulus is what? A normal stress by this volumetric strain. Na? Is that no? Like that. So shall I put the next question? That 17th question. You have to be careful in reading the question, you can say. Yeah, in YT also it is going low. Yes, yes, not live, low, live. Yes, in YT also it is going low. Same, this is screen only. I'm screening there, streaming there. In special class and YT both at a time it is going on. This class only, not other classes. Yes, Arvind answered correctly. Yesterday means on 13th April class I have mentioned this, right? This is a letter about, you can say, from special. Is there any lag for anyone? Anyone facing lag? Poll not came. Okay. Now clear? Okay. Hooke's law is valid up to, right? So what is it, you can see if you just observe, whenever it is given as na Hooke's law. Poll not came. Arey yaar. Hooke's law is valid up to which one? Whenever it is given as up to, na we have to consider it as the proportionality limit. When Hooke's law is valid within given, na that within we have to answer which one? This elastic limit, na. Yesterday also we have mentioned that question, if you remember. Up to given means it is a proportionality limit only. But if it is given within, na within is given in the question, you have to take it as elastic limit only, right? Is it clear now, everyone? Is now? Now this is 18th question. Select the answer. Yeah, tick up to. Yes. Up to proportionality limit within elastic limits. Okay, you have to be careful. According to the wording, we have to go for. Yeah, Ravind answered correctly from YouTube. Up to or within, that should be you should be very careful with those statements. Right, this is letter about. Yeah, Gaurav, Ritika also answered correctly. Right. The ability of material to absorb the energy is called as what? Resilience, ductility, elasticity, malleability. So I'll explain one by one, don't worry. What is the ductility? What is the ductility? Ability of a material to be drawn into thin wires under this tension, and malleability, ability of a material to be converted into this thin sheets under the compression action. Elasticity is what? What is the elasticity? What is the elasticity, everyone? Yeah, Saroja also answered correctly. Elasticity means ability of a material to regain the original shape and size after the removal of load. Okay, during the application of load, deformation will occur, but once you remove the load, it will gain the original shape and size, right? That is elasticity. So here strain energy related only one term is there, that is your resilience, na? So no, that is resilience only the term, na? So no, here if you just observe what is that resilience, you can say that resilience will be equal to which one? This area under which curve, tell me? Area under this load deflection curve, is not? Area under this load deflection curve, and also which one? Within elastic limit or up to the failure? It is within elastic limit only, you can say, if you just observe, right? Is not? Within elastic limit only, is not? Yes, yes, this is sufficient enough mostly, right? You just go with this, it is sufficient enough, right? Okay, you just revise some synopsis and you just go with this, that is sufficient enough, right? Now, so I'll be going on to this next one. Select the answer. Because time available is lesser now, you go with this and do quick revision, let us say. Yeah, Aravind answered correctly. Ritika also answered correctly. Solve PYQs and do quick revision. I have shared some formula sheets or something previously, if you remember. So you just, yeah, if you do not cover class, this is okay. That's why, because time availability is lesser, na, that's why within less time we wanted to get more marks without missing. That's why I'm started this series, yes, no? Out of this following, which one is least elastic, right? What is the meaning of this least elastic? Tell me. What is the meaning of this least elastic? Tell me. Least elastic means it will regain or it cannot regain. It can regain or it cannot regain. Tell me. It cannot regain, son. Yes, it cannot regain, right? Which one? Silver, iron, copper, they can regain for the larger load also. But a rubber, if you just observe, even for this chota bacha load also, with your hand itself, you just try to stretch this rubber. Will it regain? It will become extended. Na? Its length will get increased permanently. It cannot regain. So now with the silver, iron, copper wire of same dimension of rubber, if you do it with your hand, can you able to create the permanent deformation? It is impossible. Means silver, iron, copper for more load also it can regain. Rubber only for chota bacha, very negligible load only it can regain. So very small load it can regain means, yeah, small load only it can regaining, and even for small load also plastic deformations are shown, means it is least elastic. Na small load also more plastic behavior means least elastic automatically, right? Is na rubber is the answer, is na? Got it now? So shall we move to the next one, 20th question, right? Select the answer, right? This also we have written yesterday, if you remember. Yes, it regain, it shows some plastic deformation. So this series will be going on every day. Inform to your friends, juniors and everybody also, all of you, so that they will also be getting benefited. Arvind answered correctly. See, actually mostly first chapter may get over tomorrow or something like that. Same time 9:30 only every day. Same timing 9:30 to 10. This is the leaderboard, you can say. A bar L meter long having the area of this area of this cross section as A, it is subjected gradually to the applied tensile force W, right? What is that? This is your bar. Applied load is how much, you can say, that is your W, if you just observe, right? I'll share them, don't worry. I'll share them. These you can download from this class itself, na? These you can download from the class itself. So that's why I'm not sharing. If you want, I'll share these also. The strain energy stored in the bar is given by, what is that strain energy stored in the body? Tell me. So simply that strain energy equal to half into that load into the deformation, right? By default, which one we have to consider? Gradual load only we have to consider, na? So this is your, which one? This is W applied up to this point starting from 0. This is your delta you are getting. So now tell me, half into what is that load applied? W applied, area of triangle, na? Into what is that, you can say, WL by this AE will be the axial deformation, na? So what is it finally comes to be, you can say that strain energy equal to, that is your W square L by this 2AE, na? W square L by this 2AE, you can say, right? Is na? नहीं आएंगे आपके क्लास में. बैठ कर ना पढ़े तो कैसा पढ़ा ना? I don't have that board, digital board. I don't have the digital board. Then how it is possible for me? So just this is only possible, na? No? So the strain energy stored in the bar is given by, what is the concept? P square L by this 2AE or this W square L by this 2AE. Is it clear? No. So shall we go on to the next question, all of you? Shall we go on to the next question, everyone? Right. So here, go to this. I'll start the poll. See, for teaching by standing na, on the board, that I should have the digital board, Rajat Chandra. I don't have the digital board, okay? Yeah. This is the letter board, right? Yes, Garu Kumar, Harvind also answered correctly. The phenomenon, effect of an axial tension in a helical spring is, right? What is it will do if you just observe? What is it will do if you just observe? Here whenever it is a spring, na, this is your spring if you just observe. Now if you are just pulling this spring in the downward direction, right? Whenever you are pulling this spring in the downward direction, right, what happens, you can say, if you are pulling this spring in the downward direction, na, so these wires may getting twisted easily, na, is that no? So because what happens, this is the load applied W, and over this distance, right, what is this distance, tell me, right, this is your D by 2, and it will be subjected to a twisting moment is equal to the W into that R, or W into the T by 2, na, W into the capital D by 2, na. D is the diameter of this helix, right, if you remember, isn't it? Is not? Twisting will be the answer or not? Yes or not? Twisting will be the correct one, you can say, right? Now shall we move to the next one? So 22nd question, select the answer. Aravind answered correctly. Unique study answered correctly. Yes, correct, Aravind. Right, it is showing some error. Okay, and this is a letter about. Now, strain energy per unit volume of a solid circular shaft under the axial tension is, right? What is it? You can say sigma square by this 2e, na? Is that no? Sigma square by this 2e, or not everyone? It's sigma square by this 2e, right? How it has come that u will be equal to which one? This p square L by this 2ae, na? P square L by this 2ae, na? That is your strain energy, right? Yes, just now we have got the formula, na? Now, what is that strain energy per unit volume? So strain energy per unit volume means, right, it is having that length L and having the cross section area A. So what is that, you can say strain energy per unit volume means what is the volume area into that length. Here also what is that will do, divided by which one, this area into that length you do. Yes, that is sufficient enough, right? That is sufficient enough. That is what I am saying. Okay, but little bit revision also you have to do, right? Only synopsis type revision you have to do it, right? Then it will be helpful mostly, right? Now what is that, you can say, if you just observe this A and this A are there, so what is that, you can say P by A whole square we can write it, na? So this L and L get cancelled, this L and that L gets cancelled, right? P square P by A whole square into 1 by 2e, right? What is that P by A, tell me, stress, na? So that is sigma square by this 2e, right? Sigma square by this 2e we are having, right? Like that. Is that clear, everyone, how you got this? Now this 23rd question you go for. Select the answer. Okay, wait. Okay, note it, I'm waiting. You answered that also. Next question, very good. Done. Okay, now select the answer. We'll check it, which one. Do you remember strain energy expression, everyone, all of you? Do you remember the strain energy expression? Right, this is a letter board. So what is that, you can say, if you just observe, for a beam carrying a uniformly distributed load, the strain energy will be maximum in case of the beam is, right? It is your propped cantilever beam with UDL, if you just observe. Okay, Kavya, carry on. So and fixed at this both ends, you can say, right? This is your fixed beam, if you just observe. Fixed beam with which condition? UDL only, na? Next, what is that cantilever you are having, right? That is your cantilever with this UDL, and it is your simply supported with this what condition, you can say simply supported with this UDL, if you just observe, right? Simply supported with this UDL. Now here what are the maximum bending moments, tell me? What are the maximum bending moments at propped cantilever? It is how much? So this is simply supported beam, we know that is your WL square by this 8, and this is your which one, this is WL square by this 2, and this is your which one, this is WL square by this 12, And what is that? And what is it you can say? For this property cantilever, right? What is the maximum bending moment? Everyone tell me. Property cantilever, what is the maximum bending moment? All of you. Maximum bending moment for property cantilever. Anyone? Hello? Someone? Anyone tell me? From YouTube also? Nobody's. Forgot everyone. Hello? Anyone from YouTube? Anyone from special? Okay. Maximum bending moment in this property cantilever, right? Everyone forgot that? Anybody remember the values or nobody remember? Tell me. So now if you just observe, it is in between which one you can say here. This is your cantilever WL square by this 2 is there, right? Cantilever that WL square by this 2 condition is there. And this fixed beam, what is that you can say? Fixed beam, what is that? Sorry, this is your cantilever WL square by this 2. And this is which one? Fixed beam, what is that you can say? Fixed beam, both ends it is there, right? And this is your simplified beam. Now here, it will be in between those values or not? It will be in between which values if you just observe? It will be in between those values, na? So no, it will be in between those values, right? So can we say that because of this, right? Because of this, what happens if you just observe? Because of this prop created, right? This is your prop na RB. Because of this prop comes, it will be keeping the same bending moment or it will be reducing the bending effect. Tell me, it will be reducing the bending effect. Now obviously it will be reducing the bending effect, right? Whenever it is reducing the bending effect, right? What is it you can say? So it will be lesser than that of which one? This is lesser than that of this cantilever. Okay, that is fine. So simply, even if you don't remember also, you can identify that its bending moment is lesser than that of which one? This cantilever bending moment only. Now tell me if you just observe, what is the strain energy under this bending? Mx square divided mx square dx divided by this 2ei, isn't it? Bending moment under this, right? What is the bending moment under this bending conditions, everyone? Sorry, strain energy under this bending condition? U equal to integral mx square dx by this 2ei. So now tell me, when you are substituting this, more bending moment is there, more bending moment is there, more strain energy, or less bending moment, less strain energy? Tell me. More bending moment, more strain energy, or less bending moment, less strain energy? More bending moment, more strain energy. Na U is directly proportional to this mx square, right? Which one is higher for this? For this one, if you just observe, WL square by 2 plus this 3WL square by which one? This 8, is not? So 7WL square by this 8, na? This is anyone? 7WL square by this 8. Do you remember that, anyone? Bending moment for this property cantilever, maximum moment is the 7WL square by this 8. Isn't it? Any other value? 7WL square by 8 will come at which location? Tell me. 7WL square by 8 will come at which location? Tell me. That is at the fixed support. This is at the fixed support. At this place it is 0. In between it will be changing, right? Yes, that is at the fixed support, right? Even if you compare any value, whatever it is a value, that is lesser than that of cantilever only, no? That is lesser than that of cantilever only or not? Whenever it is lesser than that of cantilever, automatically it will be having which one? This is lesser. Tell me, which beam is having the highest bending moment among all of them? Among all these given, which beam is having the highest bending moment? Cantilever is having this highest bending moment. So therefore, automatically that cantilever beam will be having this more strain energy possible or not? Is not? Is that no? Right. Okay. So this last question will go for, and I am giving which one? This 60, 75, 90 seconds time I am giving. Mx square, that is. already time got over na. Okay, I'll solve this question in tomorrow's class. Okay. Solve now itself. Okay. See, simple logic in the previous one. What is the strain energy? Half into load into deformation. Yes, na? So, which one will be having more deformation or more deflections and slopes? Cantilever beam will be free to bend. More deformations, more deflections, more slopes are possible. Fixed beam, least deformed one. Okay. Whenever deformations are lesser, na, automatically what will happen? Automatically the strain energy also will be lesser, right? Simply. More supports are there, it will become indeterminate. Indeterminacy increases means automatically deformations or deflections decreasing na. Yes. So from a circular plate of which one, this is 6 centimeter dia, right? What is it you can say? The diameter is given as your 6 centimeter. It is your 6 centimeter. So what is it you can say? A circle is cut whose diameter is the radius of this plate, right? We are cutting a circle whose diameter is equal to the radius of this plate, right? Now if you just observe, this is your center of this circular plate now. Next we are cutting one plate that will be cut where? Equal to the radius, right? Whose diameter is equal to the radius of this one, right? Now can we say this one? Now can you say this is the cut portion if you just observe? This is the one which is cut if you just observe. That total is which one? This is 6 centimeter. You may get it out, sir. Where it is cut, it is not given, na? Then why you are selecting it like this only? Because if it is cut at the center, exactly center, that centroid will change or centroid will not change. If it is cut exactly at the centroid, centroid will not change, you can say. Is na? Only if you are cutting at this place, centroid will shift. The distance of center of gravity of the remainder from the center of circular plate is, right? From the center of this circular plate, you can say. How can you get that if you just observe? Got it now? Because if it is cut exactly at the center, na, that will be same only, right? It will not change. Because you are cutting right side only, there is a shift possible. Otherwise, a shift not possible. Is not understood now? Now, here what is the formula for this? That x bar will be equal to which one? This a1 x1 minus a2 x2 by which one? This a1 minus this a2 na. So this is from this y-axis, right? Yeah, now it is unsymmetrical. So this is from y-axis na. This is from this y-axis we are taking now. From this y-axis to take it, right? What is the area of this first one? Tell me. Pi by 4 into what is the, you can say, diameter 6 square into what is its original one centroid? It is at the same y-axis only, no, 0 minus pi by 4 into, right? What is the, you can say? Pi by 4 into, right? What is it you can say? Its diameter will be what? 3 centimeter na. So that is your 3 square divided by which one? Into where is its centroid present, right? From this new y-axis, its centroid of this hole is present at 1.5 centimeter distance na. 1.5 centimeter distance, right? Divided by what is that? Pi by 4 into which one? This is 6 square minus this pi by 4 into which one? This is 3 square, right? A1 minus A2, right? How much it is that you are getting? X bar from y-axis. So that comes to be how many centimeters? Finally 0.5 centimeters you are getting na. So it means minus 0.5 centimeters you are getting. Minus 0.5 centimeters means it is left side of this y-axis or right side of this y-axis? Tell me. This is x bar na. Minus 0.5, right? Minus 0.5 means left side x-axis is taken as positive or right side x-axis is taken as positive, right? Which one is taken as positive? Tell me. Left side of this y-axis is taken as positive na. Left x values are negative, right x values are positive. Or left side of y-axis it is negative, right side of y-axis it is positive, right? Like that. Shall I close the session? Yeah. Tomorrow also, yes, right side we remove, automatically it will be shifting the left side. Tomorrow again we'll continue at the 9:30 AM same time. Thank you all of you. Have a good day. Thank you.